Oh, you're wondering about that. Go ahead. Give it a shot. Let me know what you come up with. I'll tell you if you're right. All right, here we go. Graphs of sine, cosine, tangent, secant, cosecant. This is our goal over the course of the next week. Okay, you want to become excellent at graphing these. So I turn to the circle of life, the unit circle. And I'm going to generate some values here. You would need to figure that out. No, you don't. That's part of the problem. You need to figure that out. So I'm going to set the star aside, and we can talk about it a little bit. So I have the unit circle, and I'm going to make a table of values for sine of x. Is sine the x value or the y value? It's the y value. So if I plug in something for x, if I plug in, say, 0 degrees, what is the y value at 0 degrees or 0 radians? 0. Okay. How about I go to pi over 2? What is the y value at pi over 2? 1. How about I go to pi? What is the y value at pi? 0. And let's say I go 3 pi over 2. What's the y value there? -1. And then if I go all the way around to 2 pi, the y value is? Interesting. Sine is positive, positive, negative, negative. It takes a full revolution around the unit circle before it goes through all of its positive and negative values. So if I mark this out and I put the x values, 2 pi, pi over 2, 3 pi over 2. And I plot these values of 0, 0. Mark off 1 and -1. Gives me a general idea of what the graph looks like. But I'm a little bit pickier than that. I want a really good idea what the graph looks like. So I'm going to look at other values like pi over 6. Anybody know the y value for an angle of pi over 6? 1/2. Very good. 30, 60, 90. 1/2. Way to go. What about pi over 4? Root of 2 over 2, which is 0.7071. Good job. What about pi over 3? Root of 3 over 2, or 0.866. Good job. And then those values would just kind of mirror over on the other side, but on the way back down, correct? You can see the kind of shape that you get. How would you describe that shape? A wave. I like that. It is a wave. It's a sine wave. Has anybody done physics here? Anybody taking physics right now? A few people. I saw some of your work the other day. You guys were learning to graph some of these pieces. But you know, sine waves are extremely important. We would just kind of continue the pattern in the opposite direction, and we would get, you know, another graph right over here. Sine waves are some of the most applicable parts of mathematics. Our voice, as we speak, it travels from my mouth to your ear in the form of a wave. It travels, light travels as a wave. Seismographs, the things that detect, you know, the kind of the level of earthquakes as they're developing. You know, those again read waves. So this is important stuff. And doesn't take too much work to be able to graph it. The deal is that over the interval from negative 2 pi to positive 2 pi, it has a maximum value of 1, a minimum value of negative 1. We refer to the amplitude as the distance between kind of this horizontal axis and then the top or the bottom. So this is the amplitude, and it's always positive. In this situation, we say it's 1. The period is probably the part that people get confused about the most. The period is how long it takes for it to repeat itself. So you can see that that's one cycle, and it goes through another cycle. Anybody want to guess how many x units it takes before it repeats itself? 2 pi. It takes one revolution around the unit circle for it to repeat itself. Okay. Now the cosine graph is very similar. Very similar. Oh, and just kind of something cool to show you. Do you agree that 0 to pi over 2, that's the first quadrant? Right? Pi over 2 to pi, that's second quadrant, third, fourth. Where is sine positive? Which quadrants? First two. Where is it negative? Third, fourth. So you can see that it's positive up there, it's negative there. This is literally the sine graph is just the unit circle unraveled. I mean, it's all right there. If you know the sine graph, you know the unit circle. Yeah? Okay. You guys are mesmerized, I can tell. Okay, so let's move along. Another unit circle, circle of life. Cosine of x. I divide it up again into 2 pi. Cosine of 0. If I have 0 degrees or 0 radians, what is the x value at 0? What is the x value at 0? The x value at 0. Think of your terminal point. Starts with a w, rhymes with un. 1. Good job. What is the x value at pi over 2? I'm not going to say it this time. You're going to have to speak up and be courageous. 0. What about the x value at pi? Negative 1. The x value at 3 pi over 2 is back to 0. And the x value at 2 pi is back up to 1. And if I just continue this on, let's see what I get. Does it look similar to the sine graph? It does. What's that? It's just shifted. Is exactly correct. It's shifted horizontally. If I take the cosine graph and I put it up here, same thing. As I shift it, they mirror right over each other. Okay? Well, close enough. So that is your goal today. Again, over the interval from negative 2 pi to 2 pi, it has a maximum value of 1, a minimum value of negative 1, an amplitude of 1, and a period of every 2 pi. Those are the parent graphs for sine and cosine. Today, we would like to change the amplitude and the period and see how that changes the graph. Tomorrow, we'll be changing the horizontal and the vertical shifts of the graph as well. The way that we determine the amplitude is we look at the value of a in front of the function, and we take the absolute value of it. So the amplitude is always positive, and it's the absolute value of the constant in front. Same thing for cosine. The period will be 2 pi, but we then divide it by the b value. And you'll see why that is in a little bit. 2 pi divided by b. And finally, steps for graphing it. Just please note that sine starts in the middle. So if you look at these graphs, you can see that you have a maximum and a minimum. Sine starts in the middle. Cosine starts at the max or the min. One of the two. I'll show you how to determine that in a little bit. Please flip to the very back page. This is the sheet of notes that you'll get for the test. Most of you won't need to use it at all. This is the organizer I give to you. If you want to draw your axes in there, you sure can for the x and y axis. And you can see that these pieces are given to you, the amplitude absolute value of A, period 2 pi over B. So make sure you know those. All right, we're going to skip this piece. We're going to move and break this up. We're going to move to the bottom, and then we're going to do these graphs. So do it backwards from first hour. We want to begin by finding the period and the amplitude of the graphs. So we'll do the amplitude for everyone first. Okay. What is the amplitude for letter A? Yeah, it's 2. For letter B? For letter C? 1. And for letter D? So again, the amplitude is always positive. It's just the absolute value of the number in front. Is everybody okay with that? The period is 2 pi divided by the number in front of x. So the period here is 2 pi divided by 3. What is the number in front of x here? 1/4. What's 2 pi divided by 1/4? 8 pi. So 2 pi over 1 divided by 1/4. You can see that when you divide the fraction, you multiply by the reciprocal, and sure enough, you get 8 pi. For letter C, 2 pi over 1 divided by 2 pi over 5. Again, you take everything except for the x, and you get 5. And for letter D, 2 pi divided by what? 2 pi divided by pi will give you 2. Which part? 2 pi divided by b. b is the number in front of the x. Yep, that's it. Okay, let's look at the graphs. We're actually going to identify the amplitude, the period, and we're going to write an equation for it, okay? First of all, is this going to be a sine graph or a cosine graph? Why is it sine? Yeah, so it's a sine graph. What's the amplitude? 3. The period is how long it takes before it repeats itself. So I'm going to draw one cycle of the graph. So they are stating that pi is right there, and that 2 pi is right here. That's all they're drawing the graph. So how long does it take before it completes one cycle? Pi. Okay? And then within 2 pi, it completes how many cycles? It completes 2 cycles. Okay? So you know that the period is pi, but the question is, how do you come up with the equation? The way the equation is written is as follows. It's y is equal to, amplitude is 3, sine of, and then we write down how many cycles it completes in 2 pi. It completes 2 cycles, so it's 2x. Yes. So right now, if you look at this, 2 pi divided by 2 gives you pi, and that's what we said the period was, correct? So this just tells us the number of cycles every 2 pi. All right? So what do we got here? Cosine, amplitude, 4, period. Uh-oh. Well, it's a cosine graph. I start at the top. I'm going to go through one cycle. I heard it. Somebody said it completes one cycle every 2 pi. Agreed? So how many cycles does it complete in 2 pi? Completes 1. So just be y equals cosine, 4 cosine of 1x. That's my equation. Number 12. Sine or cosine? It's going to be a sine graph. Amplitude is 2. The period, what do you think? 1/2. So it completes a half a cycle. So the period is 4 pi, right? It takes 4 pi units for it to complete a rotation. So Carter's in answering the question, how many rotations does it complete in 2 pi? Just a half of a rotation, right? This is one full rotation in 4 pi. So in 2 pi, it's a half of a rotation. So it'll be y is equal to 2 sine of 1/2 x. Half of a rotation. Yes, if you write y is equal to 2 sine of x over 2, that would also be acceptable. Number 13, sine or cosine? This is a cosine graph. Period. 2 pi, amplitude 5. So no big deal. One rotation within 2 pi. What do you notice is different about this cosine graph? Starts at the bottom, so it'll be y is equal to -5 cosine of x. Again, that's a 1x, one rotation within 2 pi. All right, let's actually start to graph these, and that's going to be the majority of your work. We'll skip example 3, we'll move to example 4 and try to save some time here. And we're going to start with y equals 3 cosine of x. What is the amplitude of that graph? 3, and the period. 2 pi divided by 1, which is 2 pi. So this cosine graph will repeat itself every 2 pi. After I mark out the period, I divide it into 4 parts. Those 4 parts really show the 4 quadrants that we're rotating through in the unit circle, where it's positive, where it's negative, so on and so forth. Some people get really upset about finding the third tick mark. We have 2 pi, we have pi over 2. If we just simply count by pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. Okay, where should I start? Positive 3. Why? Because it's a cosine graph. Will the graph go up or down from there? It will go down. And then after that, it will bottom out. Where does it go after it bottoms out? Back up to 0, and then to positive 3. Excellent question. Think of the circle of life. The cosine value at 0 is 1. The cosine value at pi over 2 is 0 and then negative 1. So if you want to go from 1 to 0 to negative 1, you have to decrease, right? Yeah. So it decreases. And then after that, it goes to 0 to 1. So then it increases. Remember, as you're mapping this out, that you are showing the quadrants of positive and negative for the cosine graph. So do you recall, everybody, where is cosine positive? Which quadrants? 1 and 4. So you can see it's above the x-axis in the first and the fourth. Or is it negative? Second and the third. You can see it's below in the second and the third. So again, your sine and cosine graphs are simply the unit circle unraveled. Let's try the first one. What's the amplitude here? The period? It's 2 pi. Mark out the 2 pi. One and negative 1. Where should I start? 0. Will I go up or down? Down. Why? It is negative. The negative will create a vertical reflection. So instead of heading up, it will head down. Once I know the direction, I can then complete the pattern. Notice I'm always going between the max, the middle, and the min. Starting to get the idea? Let's skip the 4 sine of pi x and go to negative 2 cosine of x over 3. What is the amplitude? 2. The period? 2 pi divided by what? 1/3, which would make 6 pi. I'll divide 6 pi up. What is 6 pi divided in half? 3 pi. Divide that in half. 3 pi over 2. I want to come up with that third tick mark, so I will add 3 pi over 2, 6 pi over 2. Try again. 3 pi over 2, 6 pi over 2, 9 pi over 2. I'm adding 3 pi over 2 every time. You just simply want to multiply the first one by 3. That will also give you the third tick mark. However you have to think of it. It's a challenge to your number sense. Some of you don't have to think about it at all. Others of you are still confused. And that's okay. Where to start, where to start, where to start. Start at negative 2. And I'm going to go up. Repeat the pattern the other way. We have a beautiful sine graph. Now I'm going to kind of make fun of you for a second. So let me see your sense. So we're going to do it, and hopefully you'll work through your point of confusion. So I'm going to put both of these on the same set of axes so I can see how they're similar and different. So the amplitude for the first one is, and the period is 2 pi. For the second one, the amplitude is, and the period is 1/2 pi, or pi over 2. So if I want to put these on the same set of axes, should I go up to 2 or up to 6? I should go up to 6. I'll go up by 2. That will help me. And then if I want to show both of them, should I stretch out to 2 pi or out to pi over 2? 2 pi. You guys are easy to work with. Always got the right answers. Sweet. Okay, what'd you say, Lauren? No, you say because it was very intelligent. Okay, all right. Okay, all right. We're good. I'm going to graph the first one that has a period of 2 pi because I've stretched it out horizontally to match that. I think that that's the easiest way to do it. Which one did you stretch out your graph for horizontally? And so this negative 2 sine of x, where's it going to start? 0, and will it start by going up or down? Down. Super important you see this next point. This is where people got lost last hour. How is the next graph different? More frequent. How much more frequent? 4 times as often, right? I mean, if the period is pi over 2, that means within this pi over 2, it's got to complete a full cycle, right? And it goes up to 6. So I'm not going to be super exact, but this would be divided up into 4 parts. So it would go up there, then it would come back down, and it would go to the bottom, and it would come back up. You just continue to go about that. So my graph might look something like now I kind of got the hang of it. I don't even need any marks anymore. See if you could do that. Uh-oh. Elaine is laughing at my drawing. Yeah, whatever. I got you. She doesn't think I'm qualified to teach this content. It's not very like you, Elena. I expect better. You can't draw? You can't connect lines? It's not as easy as it looks, right? So now you look at my drawing, you're like, well, that's not really accurate. Why are we sketching this stuff when we know that's not really even what it looks like? Let's hold on here. If I type these into my calculator, I type in negative 2 sine of x and 6 sine of 4x. Look at my mode. I'm working in radians because I have radians for the x values, not degrees. And then also in my window, I have negative 2 pi, positive 2 pi. For my scale, I have a tick mark every pi divided by 2, and it calculates that. I put a y minimum of 6, y max of 6, and a scale of every 2 for the y value. And now I'm really excited because I think I did a pretty good job. So I'm going to press graph, and you can see the blue one in the middle. Does that look like what I have? Pretty close. And then my red marks. I mean, that's pretty much it, isn't it? I mean, I think that's pretty amazing we could do it that quickly, that accurately. Thank you, Lauren. You're the only one who appreciates it. So, all right, let's do one more example, okay? What's the amplitude for the first one? 3, period. 2 pi. For the bottom one, what's the amplitude? And the period? Yep, 3 pi. 2 pi divided by 2/3 or multiplied by 3/2. And you can see that the 2's will cancel. I'll get 3 pi. Okay, so my y values, I want to go up to what? 3. Trace. Very good. I know Spanish. And my period, I'm going to stretch that out to what? 3 pi. What's half of 3 pi? 3 pi over 2. What's half of 3 pi over 2? 3 pi over 4. And I will count. 3 pi over 4, 6 pi over 4, 9 pi over 4. Got my markings. Some people tell me they know how to do everything except for come up with the markings. So if that's you, don't feel bad. You're normal. Which one do you think I should graph first, the top one or the bottom one? I'm going to graph the bottom because the bottom is stretched out over 3 pi, and that's what I marked out. You see that? So if I'm graphing the bottom one, where do I start? -1. And for the second one, the period is 2 pi. Do you see a 2 pi up there? Do you see something close to 2 pi? What's close to 2 pi? 9 pi over 4 is close to 8 pi over 4, which is 2 pi, right? So I'm going to just kind of guesstimate. It's going to be close to that 9 pi over 4. And I have to divide that up into 4 sections. So it's really an approximation at this point. I know that you may not like that, but it's going to work out pretty well for us. And once I divide that up by approximating, I just, put my dots in place. And this is approximately what the graphs will look like. And if we plug that into your calculator, you're basically going to get that. Our drawings are very accurate. So tomorrow we're going to add 2 different shifts, a horizontal shift and a vertical shift. If you can do tomorrow's lesson, you can get an A+ on this next test. Okay. I'll get you your worksheet, and good to go. Nice job. Long lesson today.